ET 114, Chapter 18, example problem 28. It's another nodal equations problem with a couple of dependent sources. Okay, so it says write the nodal equations for this network and find the voltage across the 2K resistor, which is going to be Vx. All right, so you can see that this voltage source is dependent on this Vx. It's 2 times Vx, whatever Vx ends up being. And this current source is dependent on the current going through this resistor, which they called I1. So that's how those things work. So again, for a nodal analysis problem, you have to label your two nodes. V1 and V2 in this case is this node and this node, and then you have your reference node on the bottom, and you do KCL, or first of all, you define your currents. So this problem is a little tricky. According to the instructions, and when you have a voltage source that's dependent, you have to short it out when you do this analysis. Okay, and so what we have is, so when you short this voltage source out, V1 and V2 become the same node. So then your KCL of V1 becomes I's coming in, and then you have this current leaving going down through this Z1, because we're defining it as currents that are leaving the node are defined as, or unknown currents are defined as leaving the node. So this will be on the side of current going out. So I wrote this down for clarity. Since 2Vx is a dependent voltage source, this source here, it gets shorted during the analysis. When it is shorted, V1 and V2 become the same node, and I1 doesn't play into the equations because you're shorting this, so there is no current going through there while this short is in place. So if you do KCL at node V1, which is the same as V2, it's all one node going across like that, if you can imagine it. You have the sum of the current in, which is just going to be I, which is this 5 milliamps angle of 0, and then the current leaving going out is going to be this I2 that I defined here, this 3I1 here, and this I3 here. So then they elaborated on this equation. I2 is V1 divided by Z1, and I3 is V2 divided by Z3. Now, they defined I1, taking the short back out. I1 is defined as V1 minus V2 divided by Z2, like you would normally do it. So then what you have to do is substitute back in V2 minus V1. Yeah, V2 minus V1 is equal to 2Vx, because you're taking the voltage at this point and subtracting the voltage at this point because of the polarity, and that's equal to 2Vx. You start at the plus side. And Vx happens to equal what V1 is also, because V1 is the voltage from this point to this point, which is also what Vx is. So they say that that is also equal to 2V1. So if you solve this equation, V2 minus V1 equals 2V1, you get V2 equals 3V1. So now when you substitute all that in, you've defined what your impedances are up here as so from what you're given in the original equation. You know what your I value is. So you substitute in for V2 into this equation. You substitute in I1 for this part of the equation, and then you substitute all your values in for I Z1, Z2, Z3, and you get you get this. They simplified it down to this, and then got it down to that. And then whenever you punch in all your values for Z1, Z2, Z3, you get the V1 equals Vx equals negative 2 volts angle of 0. And then you put in that V1 back into this equation, which is 3 times V1 is V2. So that's equal to negative 6 volts angle of 0.